Thank you. My name is Andreas Kriebels. I work for OCAD, and I have 3 points on my agenda today. So first, I talk a bit about 2 recent developments. It's the function-defined paper size and the feature map generation. And then I also like to give you some insight into the OCAD Sketch App development, so the further development of the OCAD Sketch App. Let's start with the newly added function define paper size. It was developed to show you a map extent or a paper size directly into the drawing area of the OCAD window. So probably you know the problem that you have a map in OCAD and then you want to add some layout objects to it, but you're not sure how big actually is A4, for example, an A4 paper size. And there was or there is the function ruler guides you can use to show, for example, a specific extent, or you simply simply go to the export dialog and you choose there on, for example, a 4-porter in a specific scale, and then you see it in the drawing area. But of course, that's quite tedious, and when you close again the dialog, the rectangle here disappears again. So that's why we developed this function, define paper size, and when you have activated it, you see the extent you have specified, and everything else is grayed out. So it's really easy then to create a layout, for example, like this, where you can place text and north arrows. And when you start the function, you can here activate it, and as I told you, the area outside is grayed out, but you can still draw and edit objects in the grayed out area. And yeah, it's just grayed out, but it's still possible to move objects there. And then you can set the scale and a paper format, and you can also define the paper format with this width and height or directly in the drawing area. And then there is the margin, and the margin is displayed here with a dashed red line. And that's due to the fact that usually home printers will not be able to print the full size of a paper, as they need some empty borders to guide the paper through the printer. So when you define here a margin, typically 5 millimeters, then you can make sure that you do not have any important map objects or cross-setting objects between the margin and the border of the sheet of the paper. And then finally, you can save this extent, and later on it's also available in the export or in the print dialog. If you have already saved extent from the export or the print dialog, you can also load them here. So let's have a look how it looks in OCAD. You go to the layout menu, you can define the paper size, and then you can drag it or drag the paper format and define it. Here is no extent so far saved. I set the scale, I choose the paper format, then I make it fit to my map, and then I can choose a margin if that's needed, and then I can save this extent, give it a name, and you will see it's then later on also available here or in the export or print dialog. So I save it now, I close it, and once I closed it, I can not move again the defined extent. I can of course add layout objects, text, north arrow, and so on. And now when I like to print the map, I can go to the File menu, Export, and then here I can go to Setup part of the map, and you see now my extent is available here. I can load it, click OK, and now I can export the map. What is it good for? As I said, it's good for create a layout, but also there are other possible applications. For example, if you start with a new map and you want to know or how big can the map be so it fits to a specific extent, you can use this function. Or as I said, to create a layout, of course, or also for course setting purpose. You have a map, you have a course, and you're not sure if it fits to an A4 paper size. You can also define an extent in the course setting. And you see here in this example, for example, the number 7, I would have to shift a bit so the whole course fits to the A4 paper. Maybe also worth to mention, if you load a map into the as background map in the course setting module, and the map has a paper size defined, it's not visible in the course setting module, so it's not grayed out the map. You have to define a new paper size here in the course setting. Okay, that's for the first function. Then let's go on with feature map. Feature map was developed to spot near ground objects and to make them visible out of LiDAR data. So what you need for the feature map is LiDAR data, and LiDAR data for orienteering maps, it's typically produced by airplanes that are equipped with a scanner, and they scan the surface, and then you get one or multiple returns for each laser pulse. And if you have a first return, you can create a digital surface model with it. And for last returns, you then can create a digital terrain model. And when we talk about hill shading maps and slope gradient maps that can be produced with OCAD, they are based on the digital terrain model. And as you see here, they use the last return. But maybe also worth mentioning, if you have a laser beam that hits, for example, the roof here of the building, it's a last return, but it's not classified as a ground point. And for the digital terrain model, only ground points are considered. So that's the LiDAR data you get is typically classified, and the classification is done by the company that is producing this type of or this LiDAR data, and they also do the classification. And now for the feature map, we try to recognize objects close to the ground, such as stalls, walls, or tree trunks that are on the ground, that are last returns, but the LiDAR points are not classified as ground points. And that's why they are not visible so far in the hill shading maps. On this occasion, also credits to Jeff Teutsch for sharing his ideas and knowledge in the LiDAR case study, which served us as an inspiration. Let's have a look into such a LiDAR point cloud. You see here a profile. That's here the slope gradient map, and you see the profile goes from here to here. And when I look at this profile, I have 3 different, the points are classified in 3 different classes. So the green points are the vegetation points. And then I have the ground points these are the ground points, and I have also some red points. It's unclassified points. And when I look at the cross section here, I see that's in reality that's a stone here that is visible on the slope gradient map. And if I see it on the profile, there are lots of round LiDAR points, also green LiDAR points and red LiDAR points. But important is that there are ground points, so there are ground points which are used for the digital terrain model. And as I told you before, the digital terrain model is the base for the slope gradient map. And let's have a look at the other side of the profile. There you see also many points here. And in fact, that's a stone, but the LiDAR points here that hit the stone, they were classified as vegetation points and not as ground points. And that's why you can't see this stone here in the slope gradient map, but you can see it here in the feature map. And the reason you see it here in the feature map is that for the feature map generation, we reclassify the LiDAR points. So we say we take all the LiDAR points into consideration between the ground, and then we can specify a height, probably 2 or 5 meters. And then all the points here that are between the ground and the 5-meter high are reclassified and taken into the calculation. And that's how it looks in the DEM wizard, where you can create the feature map. So you can just select it, and then you have a slider where you can select the lower threshold and the upper threshold to reclassify all points above the ground, and then you can create the feature map. And when you have a look here again, maybe I have to switch to the pointer here. As I told you before, we have a lower and an upper threshold, and the lowest threshold, 0 meters, that's the ground. And here in this example, 2 meters, let's say that's here. And then all the points between 0 and 2 meters are taken into the calculation for the feature map. Here we see some examples. For example, stone detection. This is what I have shown you before. That's the slope gradient map, and that's the feature map. And you see on the feature map, you see more details. And you see here additional stone, one here, one here, one here, one here. And if you compare it with the orienteering map, you see that they are also in reality stone here, and then there are three stones quite close. Another possible use is to detect the stone wall. On the slope gradient map, I cannot see the stone wall, which is clearly visible on the feature map. Or you can also explore tree trunks, which you can see here. There is one fallen tree here, and there are 2 fallen trees here. And that helps you, of course, when you're out in the terrain to map. It helps you a lot to determine your position. And what you also see here is that I choose the threshold from 0 to 0.5 meters in this case. So you can really play around a bit with the threshold and see how much information you get out of it. So if you have a threshold from 0 to 5 meters, for example, you get a lot of other things also on the feature map, which are probably not interesting in this case. And what you see also is that the points or the point density was quite high in this example. It was 25 points per square meter. And of course, the more points you have, the better results you get. If you have low point density, the results may not be as good. Here is an example for urban areas. In urban areas, I think the vegetation height map is also really useful. You can see like walls or also cars here. You can spot them on the vegetation height map. And these are also visible on the feature map, of course. The difference is that if you have, for example, a tree here, a large single tree, you just see the canopy here in the vegetation height map, and in the feature map you really see it through the vegetation, and you can see what's on the ground or what's near the ground. Yeah. And here I'd like to show you a non-working example from Sweden. So the feature map is not working for for every terrain. The slope gradient map looks like this, and you see the feature map has so many features that it's really hard to detect. For example, a stone here or here. This stone looks really prominent on the map, but it's nearly impossible to distinguish it from from the noise around it. And why is there so much noise? I think first of all it has to do with the point density. So it's only 3.5 points per square meters compared to like 25 before. And then I think it's also the fact that in Scandinavia you have a lot of fir trees that have branches down to the bottom, and then you have also lots of vegetation points from the LiDAR data close to the ground. So probably all the small black dots are like trees with branches down down to the ground, or it may also be bushes. Yeah. Yeah, that's it to the feature map. And then let's talk a bit about the ongoing developments in OCAD. And here I'd like to give you some insight into the further development of the OCAD Sketch App. The OCAD Sketch App is widely used and also appreciated by map makers, but also by controllers, map revisions, and course setters. And we are currently putting a lot of effort into the further development of the OCAD Sketch App. And the OCAD Sketch App, it was written with tools which are to be deprecated by Microsoft this year. So that's why we started building a new app using newer technologies. And the main features you can expect is that you can not only draw and edit sketches, but now also vector objects. That was, of course, on the very top of the wish list from the feedbacks we received from the users, and it was of course also something we wanted to enable the user. Then the design should of course be as intuitive as possible for user interface and user experience. The further development of the Sketch App is also cross-platform. It will run on iOS and Android, maybe even for Windows and Mac later. Then it's multi-language. It uses light and dark mode. And there are, of course, the many ideas we have, and there are many wishes from the users. But the initial focus of the further development of the Sketch App in a first version will be on mobile mapping. And then let's have a look a bit how the prototype looks like. Left, you see the current OCAD Sketch App. And now here on the right, you see screenshots from a prototype version. And most important, as I mentioned before, you have sketch colors you can use, but at the same time you have also the symbols, and to switch between sketching and drawing real vector objects will go hand in hand. So I think that's a really advantage compared to the current version. The current version used the map or loaded the map as a rasterized bitmap as background map, and you just have or you just had the possibility to draw sketches on the rasterized bitmaps. And now with the new app, you really have also the possibility to draw vector objects and to edit them. And of course, there will also be other features or more features. You will have the possibility to load the background maps and other editing and drawing functions. So let's have a look how it looks like in a short video, just to give you an impression. You can select an vector object. You can, and then you switch to a sketch pen and select another one to map, for example, some vegetation features, and then you have some point vector objects you place directly, and then you can select a vector object and edit it. And then once again, you go and draw some vector objects. You also have the eraser as before to erase sketches. And then to redraw it. And as you see, switching between sketches or sketch colors and drawing sketches and drawing vector objects really goes hand in hand. And I think that's very important also when you're out in the terrain. You have certain features that you want to draw by as a vector, also to see how it looks like on the map, how much space you have available. And then there are other features like vegetation, mostly vegetation features that you start to sketch and that you may have to finish at another point. That's it from my presentation so far. Thanks for your attention, and yeah, I'm ready now for questions.
So thank you, Andreas, for the showcase of the latest developments in OCAD, and we already have a question from the Christer.
Yeah. You're muted, Christer.
No, I'm not muted anymore, but I pressed the wrong button. It was not my intention to have a question, but now I can have a question. I will ask you, how far away is this new version of the Sketch App until we normal users can use it?
We plan with a beta version next year. So it's always hard to say you an exact date, as it's also a bit. The question is also what should include a beta version, how many features we want to add. But yeah, it's not this year, but you can expect a beta version next year.
Okay, thank you.
Yeah.
So then we have a question from Kai Olof.
Yes, Kai Olof from Finland. Thank you, Andreas. I think often, could we have voice commands for the colors?
Well, yeah, it's a fair question. I must say it's not nothing you can expect in a first beta version, but yeah, we will take your point on board and put it also on our wish list. Yeah, thanks.
Okay, so then there are no other questions, so I will have the last question. So Andreas, please, you showed 2 examples of this feature map, one with 25 points per square meter and the another one with 3.5 maybe points per square meter. So where lies the reliable density of the input points? So can we say that with 10 points per square meter, the feature map can be okay, or what is your experience?
Yeah, it's a hard question. We did lots of tests. I think the point density is really important, but at the same time, it's all, yeah. But I can't tell you it has to be more than 10 points or more than 20 points.
So maybe
But
Dusan...
I think it's also other factors, as I showed you with the example from Sweden, that the vegetation is different. So you have really branches where you have lots of bushes or vegetation close to the ground. Then of course this vegetation will also be or there will also be LiDAR data that is reflected by this vegetation.
Yeah. Yeah, thank you.
But then it's hard. Then it's of course in terms of the LiDAR data, it's the same if it's now a bush or it's a stone. Yeah.
Yeah. So maybe Dusan Petrovic wants to add something from his experiences with LiDAR. Dusan?
No, thank you. Basically not. I would ask you, since you said that with this future option, you can reclassify the LiDAR point cloud, but you still need to input the pre-classified LiDAR cloud. Did you think and consider possibility that you would import the unclassified point cloud?
I can also my experience is that I also only work with classified point clouds, or that's the data I get when I download it from Swiss Top or from the Swiss federal
that's true.
government. I only get the classified point clouds. I haven't tried it with an unclassified point cloud, I must say.
Yeah, for instance, if you're doing your own survey with a LiDAR, there were some questions in the chat already about it. Then you got initially the unclassified, and that's why I'm asking. Okay.
Yeah.
Perhaps in the future.
Yeah.
Okay. Thank you, Andreas, for your presentation and for your answers.